Hi guys, welcome to our channel of Sciences and Mathematics. Today we're going to look at a concept in electrochemistry, and that is going to pertain to the concept of electrical work. In our previous video that we were talking about the concept of a redox reaction, we see that it involves the interplay between electricity and chemicals, and the relationship that stems from there, of course, is going to entail other forms of energy that we're going to discuss. Maybe these are other videos that we're going to discuss maybe under the concept of electrochemistry. So for today, we're going to see the relationship between work and energy that of course is involved in these electrochemical processes. So we're going to use a sample question that I've posted on the board so that we can be able to develop and understand deeper this concept of electrochemistry. So for that case, thank you and welcome. So as I've said, today's topic of discussion is going to entail a sample question that I've posted on the board, and it is going to basically be a topic on electrical work. From the concept of electrochemistry. This is electrical. So basically, as we talked about the concept of electrochemistry, we say that energy can change from one form to another, and we illustrated using the concept of a cell, a dry cell that has been joined to a light bulb, whereby chemical energy is converted to electrical and eventually heat and light. So this gives a demonstration that the different forms of energy can be changed from one form to another. And one of the forms of energy which we had of course demonstrated was electrical energy. And for today, that electrical energy, we're going to see that it's going to perform some work. And as we know, the concept of a work is a force times distance. But we're going to look at a different way in which we can be able to represent energy using the concept of electrical work. And perhaps what I'm going to introduce that is known as electromotive force. Now basically this is going to form our topic for discussion for today, since we are being requested to calculate the maximum electrical work that can be done by a 12-volt battery supplying a current of 5 amperes for 60 seconds. So from that question, there's a relationship between electrical energy, the potential difference that have been illustrated in 12V, and then the current and the time that is being illustrated. So in this case, I'm just going to start from here, whereby the concept of electrical work in electrochemistry is built from the redox reaction that we have discussed in our introduction to the concept of electrochemistry, whereby we say that in a redox reaction, the energy related to the movement of charged particles gives rise to what we call a potential difference. So therefore, if I can still use that dry cell for demonstration purposes, this is a light bulb. Of course, that is another symbol, but I'm just using that one for illustration purposes. So in this cell, there's a chemical which are reacting to produce, of course, a potential difference, which of course we have mentioned in V. So it's going to form electricity, which is going to be conducted using this conductor, and therefore it will produce light and heat as to different forms of energy. So as we have said, in a redox reaction, the energy that is released to the movement of charged particles. Now this is going to be effected through the movement of charged charges through this conductor, whereby this movement of charges basically is being referred to as an electrical current. So a current is a movement of charges from a point of high concentration to a low concentration. Now this behavior of movement of charges from a point, maybe due to the difference in concentrations, which we are going to refer to as a potential, is what we refer to as a potential difference. The variation in charges that exist between two different points is what we can be able to refer to as a potential difference. So basically this is going to be given as BD. So sometimes when we talk about the concept of a potential difference and we state the term PD, or the initial speed is going to refer to as a potential difference. Now the maximum potential difference that can be produced whenever this process or an electrochemical process is taking place is going to be referred to as, so the maximum potential difference that results from a redox reaction is going to be referred to as the electromotive force, and this is going to be designated using the term or the initial E. So therefore, from this we have seen the conversion of a chemical to electricity, and we have said there is going to be movement of charges in this particular circuit because of the difference in the amount of charges that exist between maybe the negative and the positive charge. So therefore this difference is what we refer to as a potential difference, and then we are going to see that the maximum potential difference that is going to be experienced in this redox reaction is going to be referred to as an electromotive force, which is given an initial E. So therefore we're going to designate E for an electromotive force. Now the maximum work that is going to be done, of course when there is a movement of charges, there's going to be work which is going to be done. So therefore we've got a movement of charges due to the potential difference. We're going to have a work being done by that electrical energy, and this work is going to be designated as W, and it's going to be the product of the charge. Now that we have talked about the movement of charges, this is going to be the product of charge, which we're going to give using the initial Q and the potential difference in volts. And therefore, in this case, we're going to see that we're going to have an equation to represent the same for work, which is going to lead us to the concept of electrical work. That of course is our topic for discussion for today. Therefore, we're going to have work represented as the charge, the product of charge, which is measured in coulombs, times the maximum potential difference, which we have called the electromotive force, being given as E. Now this is measured in joules per coulomb. So therefore, if we try to see the dimensions for this coulomb and coulomb, of course, is going to get to cancel out for the units, and therefore we're going to have the net units for work being given in joules. So therefore, this work can be given as the product of charge times the maximum electrical work. Of course, the maximum potential difference that we have said is given as E, which is going to be in joules. So therefore, from here we can be able to see that there's a development of the concept of electrical work from the electricity which has been used, and this, of course, which has initiated the concept of movement of charges due to a potential difference. Now the product of the maximum potential difference and then the charges, the product of charges present is going to give us what we call work. Now this is the work that we refer to as an electrical work. I can just give it an initial there, but basically we just give it as work is equals QE. So I'm going to use this concept that we have done in order to try and solve the sample question that we have listed on the board. So therefore, calculate the maximum electrical work that can be done by a 12 volts battery supplying a current of 5 amperes for 60 seconds. So the information that we have been given there is to find maximum electrical work that can be done by, so we have been given a potential difference 12 volts that can be done by a 12 volt battery supplying, and then we have been given current. Current is given an initial I, so therefore it is going to be 5 amperes for 60 seconds, and there is T, time in seconds, 60 seconds. So these are 60 seconds. So having been given that information, we have derived the equation for concept for work, which is work is equals QE. And then we are going to see that charge can be given as current times time. So therefore the equation for work for us is going to be current times time. This electromotive force is going to be measured in terms of volts. That is the potential difference. So therefore we can illustrate our concept of work using work equals VIT. And therefore we will go ahead and do a substitution for the information we have been given in order for us to find work. So for V we have 12 times the current is 5 amperes times the time is 60 seconds. So this is going to be in joules, which is going to be, this is already 60 times 60. So therefore this is going to be 3600 joules. So this is the amount of electrical work which will be done in this particular case for this electrical work. And basically this is how we are going to maybe try to work out most of the questions that you have been given that entails the concept of maybe potential difference, currents, time and work in some of the electrochemical questions that we are going to come across. So I hope that we have understood that concept using that illustration for the sample question that we have used on the board. And this is going to assist us maybe develop on other concepts of trying to find solutions for questions that are regarding to electrochemistry. So that is it for today. Bye guys. God bless.